Consider the cubic polynomial y equals x minus 1 all squared times x plus 2. For part A, we want to expand the expression x minus 1 all squared times x plus 2. So expanding this out would give x squared minus 2x plus 1. So that's the expansion of x plus 1 all squared. And then that would still be multiplied by x plus 2. Next, we can set up a grid to expand this. So we're going to put x squared minus 2x and plus 1 along the top. And we're going to have x and positive 2 down the side. Next, we're going to multiply the term in the top of each column by the term in the side of each row. So we're going to have x squared times x gives x cubed. Then minus 2x times x gives minus 2x squared. Then 1 times x gives plus x. Then x squared times positive 2 gives positive 2x squared. Minus 2x times positive 2 gives minus 4x. And 1 times 2 gives 2. So we can see that minus 4x and x are like terms. And we can also see that positive 2x squared and minus 2x squared would cancel. So adding up all of those cells and collecting like terms would give this expression is equivalent to x cubed minus 3x plus 2. For part B, we want to determine the derivative, which we can represent as dy dx. So dy dx is equal to, and this is why it was important to expand out our factorized form, because we don't have the skills yet to differentiate factorized forms. However, in expanded form, we simply take the power out the front and subtract 1 off the power, which would give us 3x squared minus 3 as the derivative of this curve. For part C, we just want to find dy dx, or the derivative when x equals negative 2. So for this question, we can write dy dx, and we can represent that we're going to evaluate it at x equals minus 2 by using this straight up and down line and then writing x equals minus 2 next to it. And that's going to equal 3 times minus 2 squared, subtract 3. And then that's going to be 3 and minus 2 squared is times 4 minus 3, which is equal to 12 subtract 3 is positive 9. So that's the value of the derivative when x equals negative 2. For part D, we're asked to find the coordinates of the stationary points of the cubic graph. So to find the stationary points of a graph, we can understand that to be when a tangent line would have a gradient of 0 to the curve. So that means that we can solve dy dx is equal to 0 to find the x values of the stationary point. From the previous slide, we know that dy dx was equal to 3x squared minus 3, so that is going to equal 0. And then if we add 3 to both sides, we find that 3x squared is equal to 3, and dividing both sides by 3 will give x squared is equal to 1, therefore x is equal to plus or minus 1. Next, we need to find the y value so we can state the coordinates of the stationary points. And to do this, we're going to take our x values where we know the stationary points occur and sub them into the original equation. So if we consider x is equal to negative 1 first, that will give us y is equal to negative 1 minus 1 all squared, and then minus 1 plus 2 in the second bracket. Therefore, y is equal to minus 2 squared, which is 4, times 1, which is just 4. Next, we can consider the stationary point that occurs when x is 1. And that will give us y is equal to 1 minus 1 all squared times 1 plus 2. Therefore, y is equal to 0 times 2, which is just 0. So this will give our stationary points when x is equal to negative 1, y was equal to 4, and the stationary point when x is 1, y is 0. For part E, we want to sketch the graph of the cubic function y equals x minus 1 all squared times x plus 2 on the set of axes provided. So when we sketch a graph, we need to label all of its key features, and we've already found the stationary points. So what we now need to do is find the x and y intercepts. So the y-intercept of the graph is going to occur when x is equal to 0. Therefore, y is equal to 0 minus 1 all squared times 0 plus 2. And that will give us y is equal to minus 1 squared is 1 times 0 plus 2, which is simply 2, which equals 2. So that means we have a y-intercept of 0, 2 on the graph. Next, we want to find the x-intercepts of the graph, which occur when y equals 0. And if y equals 0, we're solving 0 is equal to x minus 1 all squared times x plus 2. And if we use the null factor law, that would tell us that x minus 1 could equal 0, or we could have x plus 2 is equal to 0. For the first equation, we can add 1 to both sides to solve for x, and that will give us x is equal to 1. And for the second equation, we can subtract 2 from both sides to solve for x. Therefore, x is equal to minus 2. So our x-intercepts occur at 1, 0 and at minus 2, 0. So keeping in mind all of those key features, we can sketch our cubic graph, and now it's a positive cubic that will go up, come down, turn, and go up again. So this point here was the x-intercept at minus 2, 0. This was the x-intercept at 1, 0, and also a turning point. This turning point was at negative 1, 4, and our y-intercept was found to be at 0, 2. So that is the full sketch of y equals x minus 1 all squared times x plus 2.